Okay, here's example 5 from 4.1. We're going to talk about finding those absolute extrema without a picture. So in number 5a, it asks us to find the extrema, that's the absolute maximum or minimum, of our function, which is 3x to the fourth minus 4x cubed, on the interval from -1 to 2. So I have some sort of a graph. We're not really sure what it looks like now. We have endpoints from -1 to 2, and in that interval we want to figure out where our absolute highest value is and our absolute lowest value is. So we talked about the steps in the last video, where the first thing we want to do is find our critical numbers. We want to figure out where all of those possible highs and lows are, where the derivative equals 0, or possibly where the derivative does not exist, maybe some sharp turns, something like that. So before we find our critical numbers, we've got to find our derivative. So if you'll find the derivative of our function, please. You should end up getting the derivative as 12x cubed minus 12x squared. Let's go ahead and use that derivative then to find our critical numbers. That's where our derivative equals 0 or does not exist. In this particular problem, our derivative is just a polynomial, so it's not going to not exist, it's only going to equal 0. So that's what I'm going to do. I'm going to set it equal to 0. I'm then going to solve, so do that for me. Maybe pause the video, solve it, and see if you get the same answers as I do. I factored out a 12x squared. I set them equal to 0, and I got critical numbers at x equals 0 and x equals 1. So I have critical numbers here. These are my critical numbers where the derivative equals 0. That's where I possibly have those highs and lows, right? Where my derivative equals 0. Now, I don't know where those highs or lows what the y values are of those highs or lows. And so that's what we have to do next, is we've got to figure out where those highs and lows are on the y value to see who's the highest and who's the lowest. So I'm going to take my original function, because I want to figure out where I'm at, and I want to plug in those critical numbers. So I'm going to take my original function, and I'm going to plug in my critical number of 0 into my original and 1 into my original. And so here's my original function. I'm going to plug in 0, I'm going to plug in 1, and I should get, something erased here. I should get values of 0 and -1. Did you get those same numbers? Okay, so that's where my little humps are, right? My highs and my lows. But who could be higher or lower than those critical numbers or those relative extrema? Well, can I have endpoints that might be higher or lower? And so what I have to do is I also then have to test my endpoints. Remember, my interval was from -1 to 2, so those are my two endpoints. I want to test -1 in my original. I also want to test 2 in my original to see if those endpoints are higher or lower than those humps. So plugging in -1 to your original, you should get 7. Plugging in 2 to your original, double check, make sure you get the same answer as I do, I got 16. So now I have 4 possible places where I have highs and lows. Out of those 4 places, which one is my absolute maximum and which one is my absolute minimum value then? Well, I can compare the y values to see who my high and my low are. So I got an absolute minimum when x is 1. What is your absolute minimum? We can say -1. And I have an absolute maximum when x is 2. What is your absolute maximum value? We could say 16. So depending on what the question asks us for, we've got to be careful. I have an absolute minimum at the point 1, -1. I have an absolute maximum at the point 2, 16. You could always double check by plugging your original function into your calculator and graphing it. You should actually be able to see where your highs and your lows are and double check that this makes sense, that your lowest value is at the point 1, -1, and your absolute highest value is at the point 2, 16. Plug it in your calculator, see what you get. Let's do another example in this same video. Let's do example number 5b. So we've got a new function, and it asks us to find the extrema again. So our new function is 2x minus 3x to the 2/3, and we're finding the absolute extrema on the interval from -1 to 3. So let's follow our steps. Let's find our critical numbers. Let's take those critical numbers and plug them into the original. But let's also test our endpoints in our original to see who our highest value is and our lowest value is, our absolute extrema. So the first thing we have to do before we find our critical numbers is find the derivative. Pause the video, practice your derivative rules, and see if you get the same derivative as me. You should end up getting 2 minus 2x to the negative 1/3. I'm going to take that x to the negative 1/3 and I'm going to drop that down to make them a positive exponent. So now I have 2 minus 2 over x to the 1/3. I put the 2 over 1 so that I can compare and see that they don't have common denominators. And so it's going to be a little bit easier for me to combine them into a common denominator so I can go from there and figure out where my critical numbers are. So I multiplied this first one by an x to the 1/3 on top and bottom. And so now I have a new derivative with a common denominator that is 2x to the 1/3 minus 2 on the top, the numerator, over my common denominator, which is x to the 1/3. If that's my derivative and I want to find my critical numbers, we know that critical numbers are when the derivative equals 0, maybe those smooth curves, or when my derivative doesn't exist, maybe those sharp curves. And so when I have a fraction and I want to figure out when that fraction equals 0, doesn't the top have to be 0? Because 0 divided by a number is 0. And so I'm going to set the top equal to 0. That's when my derivative is going to equal 0. But I also want to figure out when my derivative doesn't exist. And so if I have a fraction and I want my answer to not exist or be undefined, then I want the denominator to be 0. And so I'm going to do that. I'm going to set both my numerator and denominator equal to 0. This is when my derivative equals 0 and when my derivative does not exist. So I'm going to set up two different equations and I'm going to solve both of those equations so I can find my critical numbers. I'm going to add 2 to both sides. I'm going to divide by 2 and I end up getting an equation that says x to the 1/3 equals 1, right? I'm then going to cube both sides and I end up getting a critical number at x equals 1. I'm going to do the same thing for the other side. I'm going to cube both sides and I end up getting another critical number at x equals 0. And so my derivative equals 0 when x equals 1, so I maybe have a smooth curve there. My derivative doesn't exist at x equals 0. I might have a sharp curve there, but those are my two critical numbers. My next step, now that I've found my critical numbers, is I'm going to take those critical numbers and plug them in. Remember, we're going to plug them in though to my original function because I want to know where I'm at. Not necessarily what my derivative is anymore, but where I'm at that point. But who could be higher or lower than those critical numbers? Our endpoints, right? So not only do I want to plug in my 1 and my 0, my critical numbers, I also want to plug in my endpoints, -1 and 3. I'm going to plug all of those numbers into my original function and see where I'm at, what my y values are. So pause the video, plug in -1, plug in 0, plug in 1, plug in 3 to the original function and see what you get for your y values. See if they match my answers. I ended up getting -5, 0, -1, and -2.40. Did you get the same thing as me? Okay. So now that I have these four values, I can compare which one is my absolute maximum and which one's my absolute minimum. So looking at those values, it looks like I have an absolute maximum at the point 0, 0, and I have an absolute minimum at the point -1, -5. Double check, plug that function into your calculator and see if you have a sharp turn at x equals 0. See if you have a smooth curve at x equals 1, and see if those absolute